All right. Hi, everyone. My name is Gab Messenger, and I am the GA for the Research Commons. This is the last Common Quandaries workshop for the month of November, so thank you for joining us. Our Common Quandaries workshop will be right from the start, designing data collection with purpose. Our presenter will be Jordan Sly, who is a librarian for the University of Maryland. It should be a really fun presentation. If you have any questions, you can throw them into the chat. I'm sure there will be time to ask them at the end. And take it away, Jordan.
Hey, great. Thank you, Gabby. Hello, everybody. As Gabby said, my name is Jordan Sly, and I'm a research and instruction librarian here at the University of Maryland. This workshop is overall a part of the Research Commons Common Quandaries series, which we have many of throughout the year. And we offer different workshops and different series and everything through the Research Commons. So I just wanted to kind of give a quick advertisement for that, a couple different things there. And this is where you can find more information on these workshops and things. So before we get started, I just wanted to kind of throw that in the mix. So the purpose of this workshop is to help you think about data collection in a holistic way, and to help you think about and understand the life cycle of data that begins before the project even officially begins and continues even after the project has ended. That's one of the main kind of orienting factors that we're going to be talking about here. So I hope this workshop helps in kind of a broad sense for a lot of your work, wherever that may be. Everyone usually comes to this from a wide range of experience levels and departments and so on and so forth. So as a factor of that, I wanted to point out that this is a beginner's workshop. Given the time constraints and the difficulty of communicating more complex ideas through video chat and all of this, we can't go into a whole lot of depth into any one idea that we're going to be talking about, and we're going to be talking about quite a few things. Additionally, because this is a multidisciplinary workshop, we need to stay somewhat vague as we go through these ideas. So as you're hearing things, make sure to kind of think about how or if it applies to the work that you're doing. And we can address specific things in questions. And I'm also available for consultations after the workshop through the rest of the semester and into the future as well. So just as a general introduction to what the library does, there are many different people who work in different facets of data. And I'll kind of explain this a little bit more at the end of, we're looking at some resources for actually helping. I'm one person of many. I work with departments in the social sciences, anthropology, and psychology. Psychology being a very data-driven discipline. So that's an area where I work a lot in data. My own research as well is in the digital humanities. And I work with a lot of data there as well. So I kind of skirt amongst a lot of different areas to work with data, but not everything. So there are components of data, for example, with geographical data, things like this, that I don't have as much experience in and would forward you to my colleague Milan, for example, who would be a much better person to help you. Same thing goes if you're coming from computer science or engineering, things like this, I would forward you to my colleagues in the STEM library who would be better equipped to help you with those very specific things. But as a general introduction to a couple of different concepts, I hope this workshop can help you with a number of different things. Okay. And again, if you have very specific questions, I can help you or forward you along. Another focusing and steering element of this workshop is the library framework. So the orientation that we're taking has to do with the library and the way the libraries can help you through your data process. So it's not going to be the same thing as like a methods course in psychology or something like this. Like we can't go through every little element that we would there. And through this discussion, I'll add elements about how the libraries can help you through the research process and how the libraries can offer more than just sort of simple resources like books and databases and articles and things. Again, these services include statistical consultations, like with my colleague I mentioned before, and others, data management consultations, data sources, such as data sets from places like ICPSR, other repositories, among other things, including workshops like this, and other workshops that are on more specific aspects of the research process, such as systematic reviews, workshops on programming and analysis software, such as R or SPSS, and others, as well as workshops in writing on workshops in writing and publishing, all these things related to the work. So the full scope of the research cycle. Today, as I mentioned, we're going to be looking at one aspect of the research process and how looking at these things strategically, how a strategic collection of data can help with the actual output of data. So thinking about data collection, data management, and data practices for eventual output, and how good methods along the way can ensure good outputs in the end. In other words, we're looking at how to use and store data appropriately, and how the actual collection of data can either facilitate this goal or hinder it right from the start, like the title, you see. Okay. To do this, we're going to first look at defining data in a couple of different ways. Again, this is not a methods course, so we're going to be taking something of a bird's eye view of this topic and hover around some generalities as opposed to taking a discipline-specific approach to data modalities. We will, however, look at multi-dimensionality of data and how we can account for these dimensions in our collection in order to enhance our output with a little bit of extra work. So with that, we're going to look at data output with relation to data collection in terms of organization, presentation, and preparing for analysis. To do this, we're going to also look at notions of tidy data as a component of the larger philosophical notions of research data collection. We'll then move from those basic principles to some notions of data management and storage, and think about terms of best practice and other considerations along those lines. After that, we'll take a brief look at some software tools available to you through UMD, and what you can do with your data-related questions in the library. So we should have plenty of time for questions after that. And there we go. So this presentation is something of a compilation of other workshops I and my colleagues have given over the past few years here in the Research Commons and the Common Quandaries series. And as such, I need to give particular credit to my colleague, Dave Durden. He's the UMD Data Sciences librarian, who unfortunately couldn't be here today. And additionally, my colleagues, Sarah Over, Nedelinga Chengolova, Stephanie Ritchie, and others who have helped in developing not only the series, but the data focus that a lot of these workshops have. Additionally, I would also like to thank my colleague, Linda Macri from the Graduate Writing School. She's helped in a lot of the sort of framing for some of, not only this workshop, but some of the others for the research output sections. Previously, David Durden and I gave 2 workshops on tidy data principles and best practices for data management, which are referenced here a lot, as in taken directly from some of those presentations. And again, along with some other materials from other workshops, you can find all of these in the workshop materials library through the Research Commons. And I just wanted to put a quick plug in for that so you can check that out. And I can share a link for that a little bit later. And finally, before we actually get started, I just wanted to give a quick announcement for the UMD Data Challenge 2021. This is a fun way, if anybody's interested in something like this is a fun way to start working with data and dipping your toes into the world and doing it in a team-based environment, which can often facilitate quite a lot of learning. If this is something you're interested in, please note the quickly approaching deadlines that it has here and check out the information here. Again, I can share links later. Okay, so let's move into the first content area. Now, this is a bit of an obvious question, and I promise we're not going to dwell on either overly simplistic notions or delve too far into very complex philosophical ones, but it is worth stating a few definitions that would help us move forward. Within a research context, data is essentially the units of information by which you define your observations in multiple ways. Data can be complex geographical information, health metrics, creative and research texts, focus group responses to survey questions, inventories, tweets, census information. The list goes on forever. The data is the observation, the thing that you can take from your research. And it includes both quantitative, meaning numbers, and qualitative, meaning words or feelings and sentiment and things like this. There's a broad tent for data. And we're kind of using all of it as we go through this today to try to kind of skirt across a number of different factors to help keep some relevance, right? these are all basic single dimension nodes of data, the ones that I've mentioned. An answer to a survey question is a one-dimensional answer. If we have a survey question such as this silly one, are you ready for Thanksgiving break? This is a very singular answer, right? We get a kind of static dimension that results. The 14 responses create our basic data set. So we have some data and we have a data set now. But the problem is the more data we can collect from, there's basically more we can be doing with this than this very, very basic response, right? So we have a series of things we can do something with. So we do have data and we have a data set, but there's actually far more that we can learn from this very basic data if we wanted to delve in a little bit further. Multidimensionality in data is essentially, and this is of course an oversimplification, but it is essentially the structure of data, metadata, and other associated components that contextualize analysis of a particular data node. In other words, it's a package of data that comes along with a seemingly individual data point. Language around this is a little bit tricky because in different disciplines, some exact notions of what data are different. So to avoid confusion, I'm going to remain a little vague here. So the idea with the multidimensionality of data is it's the singular aspect with its multiple children, right? So what are the things that all create this sort of contextual information? From data point A, this is from our silly little survey, we can see that 10 people responded that yes, they are ready for Thanksgiving break. I am amongst those. We have very little else that we can see with this data presented. However, when exporting the data, even into a simple program from Google Forms into Google Sheets, like this is not complex anything, we have some added data automatically added without any effort, right? Well, it's not thrilling information. This timestamp data does allow some further analysis of our original data. So now I can compare the time entered for the various results to create an analysis of which, what responses were recorded at what times, and if that matters. Maybe it would be of interest to my study to understand that all of the people who answered that they will not be celebrating Thanksgiving this year answered on a particular date, for example, or at a specific time. Now, this is a silly and overly simplistic version, but the larger question still remains. What is the data we can pull from a singular answer? And this is one of the central questions to consider with data collection. How can I make all of these elements cohere by pulling together their relationship? This is something we're going to kind of extrapolate through, multiple steps here. What I'm trying to, so the questions to sort of be framing, the sort of animating conceptions behind this is, what am I trying to assess through the data? What are the connective elements that would give me a correlative information, and how will this be represented? So right from the beginning, it's important to start thinking about how this information will be linked together, in what form, and what are the important elements that create the mode of your analysis. By connecting two things to make a correlation, why is that important? And how will that be represented? If we keep digging into our silly Thanksgiving question, we can start to add some of this information that will allow us to better understand the value of each answer. As it stands, a yes response, a no response, etc., it means very little. True, we get a basic snapshot of a direct answer, but there is no ability to conduct any meaningful analysis of this data. Likely, it would be helpful to know the names of the respondents, for example, but that isn't always possible or ethical for various reasons. In programs like Qualtrics or REDCap, there are tools for creating identifying numbers that can locate the information of a singular response while de-identifying the actual respondent. So that gives us something. There's a relationship there. In Google Forms, you can do similar things, but with a little more work, a little more effort. But the important thing here is the clustering of responses to co-locate data is the kind of necessary element here. So that way, if you're locating something like the user entered data, which is the yes response, and the machine entered data, which is the timestamp here, you want to try to locate those two things together as an example of multidimensionality. This isn't the only example, of course. IP data, for example, can help locate a user geographically. Information about web browsers can provide user information about how your users are connecting with you, what time they're responding, etc. The point here is that there are useful points of analysis even at the simplest level that can add depth to a project. From this survey, we'd have to think about what we're really looking for, what we care about. And now again, I'm treading lightly over this topic and I don't want to verge into a lesson on survey design. And we're thinking purely about data collection and output here. But these notions are obviously intertwined. There are too many specifics to get into with any level of accuracy, but what is most important is thinking about what the data looks like in the form of a data set. What are we going to do with it once it's recorded? What are the goals of the output? That's the important thing that we want to kind of look at, especially when we start looking at tidy data. So just to reiterate what multidimensionality means, because I did kind of skim through that fairly quickly. So multidimensionality is essentially the extra nodes that you can connect to a singular node. So you have, factor one here. What are the things that you can add together to create your understanding of that factor? I think there's more on that as we go here. It starts to become a little complicated when considering the multidimensional components of research data. The more I add to a data set, the more I can work with, true, but also the more that can be there to kind of clutter things up in the data set and confuse my analysis methods. And importantly, if you're doing computational methods for analysis, ways you can kind of goof up the program, like R or something like this, and spin your results in a completely wild fashion. We'll talk more about that with tidy data in just a few moments here. So if we were working with our basic survey data, we could clutter our questions with as many questions as we wanted. We could ask how long the respondent has been a part of the university. We could look at questions of race, gender, ethnicity, sexuality, income. The dimensions could extend really forever, but to what end? Would those data points help me understand my central question? So again, we're kind of coming back to collecting with an output purpose and knowing where it is we're going from the beginning. So in this example, going back again to this example, this example, our Thanksgiving question. Let's say I'm interested in understanding how various people at the University of Maryland feel about Thanksgiving break, and that we're looking to understand feelings of anxiety surrounding this difficult semester, because it is a difficult semester for all of us. Our goal is then to ask questions that we can work with both individually and correlate it. Again, remembering the point of this is to connect nodes. Think back to the overly complicated data association flowcharts that we looked at before, which is something like this, right? The goal here is to have enough correlated data points to find meaningful insights, but also to have an ordered structured data approach to the collection, storage, and management of this data, or storagement. We can create a neologism there. Collection, storage, and management of this data. So the idea here is we have a map of the things that I'm kind of abstracting, right? Now this comes from a developer's guide in sort of computer management and network analysis and things. But the idea here is we have what it is that we are connecting all of these nodes to and a map of relationships. So in data collection, the goal is largely to have something like this to refer to, a map and a plan, in order to not only create the associations, but to give yourself a plan and your readers, or the people who may be following up with your data later, an understanding of what the relationships are and their values to each other. That way, random variables that may exist cohere within the larger structure. Okay. So with our example, I made a very simple version of this, right? So with our example, we're looking at this packet of information associated with an organizational data point. So we'll kind of use this as our organizational data point. This is our output model. Ideally, these are the dimensions that we can look to analyze, right? Kind of represented in this chart. Now, this is a quick sketch of an output model that we can map, where we can map the purpose of the data collected. This is a very simplistic one, of course, but you kind of get the idea. So we have a simple question that we're asking here. Now, we can, of course, continue to build this out, but the core point is simply that each variable and dimension relates back to its root. We're going to use this essentially as our root. In this case, our primary anchor point is the respondent's role. That'll be our organizing point for our organization packets or information packets, as the remaining data stems from its relationship to the central node. Each one of these things, I'm pointing at my screen, you can't see. Each one of these things doesn't mean a whole lot without its connection to its previous parent, right? So if they feel a particular way, it doesn't mean anything if you don't know the step before it. And if you don't know their relationship, it means a little bit less, right? Because you can only make a very summative point from there. By mapping out our ideal output, we can begin to create our data collection methods to ensure that these outputs, to ensure these outputs by avoiding unnecessary facets. In other words, not cluttering things up. This isn't always possible, of course, as data comes from multiple forms. We've talked about a somewhat clinical and clean example with this, with just very, very few variables and very few information sources. So that way we can kind of boil down some of this essential elements here to make a point. But when using someone else's data, for example, or using a much deeper and larger complex data set, cleaning or refining is a necessary step, but with a similar mindset of simplicity. The information mapping is still a vital component of the refining process, as it clarifies the necessary data and calls out what's unnecessary. In other words, no matter if you're collecting the data yourself or using someone else's data or a larger data set from the census or something like this, understanding what it is you need is the crucial component in making your analysis. The software that you'll be using to do data analysis in a quantitative way or a qualitative way requires a really clean output. Right? If you have too many things cluttering up the way your input for this, it will mess up your analysis. Again, we have workshops on things like R. If you need help with those specific things, we're not going to be going into depth on those. But again, keeping the data clean, as we'll talk about, is a very, very important part of this. And I'm using words like refine and clean the data and things like this. And this will become a little bit clearer if it's unclear at the moment what that means and how to do it, or rather what tools you use in order to do that. I'll make that clear as we go. Okay, so here's an example from my own research. In this first sheet, you see a fairly ordered spreadsheet with a clear set of data and data categories and things leading across the top. This is not how it came to me. This is scraped data, means that it comes from a large database and it pulls from various different organizational fields within the larger data set. And it has its own organizational scheme. And so I needed to make it kind of cohere and work for my organizational scheme, as these things would become kind of scattered all over the place. Now, this is using tools like OpenRefine, which I'll give a link for later. You can pull these elements together and make your data into something usable. And one thing I'd like to point out here is, if I can find my mouse, here we go. What this allows me to do, right, by having these nodes be fairly clean across, I can say any one of these can now become my central anchor point. If we go back, to these diagrams of the relationships, any one of these now can become my anchor point for analysis. So when I plug this into my analysis software, I can decide that, let's see, the author perhaps is going to be my anchor point for my different analyses. And then I can read data both from here in sort of in a crosshatch way. I can read it in either direction. I'll explain that a little more when we get to tidy data, about the sort of principles of hierarchies of data and things like that in this context. But this is the structured way of kind of isolating an element and being able to find its component children following that. Okay, I feel like that was less helpful than I wanted it to be. So the idea here is now I can weight these nodes as I enter them into my analysis software, right? Each one of these individual instances, and this is the important part again when we get to the data that I didn't quite make clear in my last sentence here, is there are ways, and it may be tempting to make each one of these, for example, instead a column, right? So to say Adam Islip is a column and here's all the information that follows after him, something like this. For the analysis software, what is more helpful is the fact that Adam Islip appears 4 times here. What that means is that this in and of itself becomes data, right? The fact that Adam Islip is here 4 times is in and of itself data. And that's an important sort of orienting module to think about as we move forward through this. Every aspect of this spreadsheet is analyzable. Okay. In other words, I knew that in my data mapping through this project, right? So this is the kind of thing that was handed to me through the scrape data. It is just this nonsense. So if we go back and look at the cleaned up version, you can see some pretty big differences here. And I knew that through my data mapping that I wanted to be able to isolate the individual authors, their works, and the date and the location. Those were the things that I wanted to be able to associate with it. It's not worth going into all the details of what my research is for this, but I wanted to be able to link these things together, right? And especially these two things as central nodes. So in my data chart, the thing that I drew up to understand where I wanted my data to go, that's how I organized the next step of it in organizing that spreadsheet, right? I needed to keep some of the data from the original data set, but not all of it. And by cleaning it and honing it, the anchors and the variables were clearer, and I was able to do machine analysis that I couldn't do with this dirtier data. This allowed, when I cleaned it up, it allowed for visualizations because what I'm putting into my visualization was a much clearer picture of what it was trying to visualize. Now, there are still some elements of data, metadata here that I can use for analysis, such as the cataloging information for each book, for example, some of this information over here. But that's all specific to this project, and I don't need to go into depth about that. But the idea here, again, is that everything on that sheet is data in one way or another. So if we go back to our kind of animating question from the beginning of what is data, it's a vast question with a lot of different answers. Now, I can choose now what parts of the data I want to connect, like I was just saying a moment ago, and show these in basic ways of highlighting and weighting of different anchor nodes through geography, creator information, date, etc. And you can see this as I move into the actual project, right? I can start to link these things based on how I want them to be weighted and connected between each different node. Each one of these charts demonstrates a different anchor node that I'm then connecting to different elements, right? So all of this is just a visualization of this spreadsheet focusing on a different node that I'm pulling from here. So whether or not I'm focusing on the author as the sort of centralizing node, the title or the publisher as a centralizing node, or the place, the place it's published as the anchoring node. Each one of those components gives me what it is that I'm looking for. Okay, that's a lot, right? There's a lot in data organization and even the sort of opening, principles of how these things go. And so I hope there'll be some questions about this later too. I want to note an important book for understanding some of this. And I'll point out a couple of resources as we go that I hope you take note of. But this one is a very good introduction to a lot of the things that I've had to kind of skim past fairly quickly. This is called Data Management for Researchers. And this is a good book. It's a little pricey. It tends to hover around something like $40 or so on Amazon, but I have seen secondhand copies here or there for like 20, depending. It's fairly new as these things go, but it is a very good book. And it's where we've pulled a lot of our information about how to do research data from. So if you have questions about all of this, this is a good place to go to start looking for it. Okay. So now we can move on to tiny data. Tiny data is cute. It's fun, right? It's the idea, the principle behind it is, I would even say, or did I say tiny? I meant to say tidy. I have it written, sorry, excuse me. It's still cute and fun. But the notion here is clean data, right? We want to make sure that the data that we have serves our exact purpose and does little else, right? That it represents what we need it to represent. So we don't have the ability to go into every facet of what tidy data is, but these are the basics here. The idea is to put your variables into separate columns, which you remember from my spreadsheet before, to put each observation or child in each row itself, and then each cluster of that becomes a table. So then if there's another facet that I want to look at, it's a different data set. Okay, I'll explain a little more about that as we go. And specifically, you want to avoid combining multiple pieces of information into one cell. That confuses the spreadsheets and more importantly, the analysis software that you're looking at later. By cramming too much into one spot, it disallows any sort of analysis that could really happen. Make sure to keep at least a version of raw data that exists so that you can go back if there are problems. Create more spreadsheets as opposed to combining spreadsheets, and try not to leave anything empty. So these are some of the sort of fussy points of the tidy data about sort of the actual, sort of tidiness of it, the look of the spreadsheet, the minimalist approach. with some of this. Now, this article, Wickham from 2014, Tidy Data from the Journal of Statistical Software, is pretty much the best one, right? There are some others. Most of the others are case studies about how to do it. I mean, there's a bunch, so it's hard to see. But I do recommend grabbing this article to learn a little bit more about Tidy Data, the basics of which are kind of outlined in about the first 5 or 6 pages. So you can kind of get the point fairly quickly. Okay, so I'll be pulling from this article extensively in this section. And like with the mentioned notes about planning and modeling data, Tidy Data is a method for organization of data that allows for the ease of use and the clean presentation of data by intelligent groupings and a foundation of order to single out variables and other data points quickly and logically. So even in this quote, we can see Tidy Data is a standard way of mapping the meaning of a data set to its structure. A data set is messy or tidy depending on how rows, columns, and tables are matched up with observations, variables, and types. That is the main principle of Tidy Data right there. So again, this is just reiterated from the last slide. Each variable forms a column, each observation forms a row, and each type of observational unit forms a table. Now, I have a tattoo of, no, I'm kidding. These are important to remember, and it's the difficulty in putting this together, but it's really kind of the point of a lot of this workshop, right? To plan from the start to create Tidy Data, and your output will be markedly better. Okay, so here's an example. This is a sort of what not to do, these two here, right? So in example 1 and 2, we can see a record of the data collected. But while this is human readable, we can figure out what's going on here. It's difficult to translate for computational analysis. Why? Well, we have in each example here a situation where each column and row is dependent on its structure. In other words, we're trying to run an analysis of this data set. We would have trouble parsing the data in the way that a program or like R or SPSS, et cetera, would like. Now, however, if we look at an example of Tidy Data and for the same set, we can see how clearly each row displays all the necessary information if we plug it into a program like R and stuff like this in a row, right? And again, remember, rows are the horizontal categories in a spreadsheet, and the columns are the vertical. Right? So when I say row and column, that's what I'm talking about there. In other words, if I'm running an analysis and I'm putting in my observations, in this case, my name against variables, and in this case, the trial and result, I have a clean left to right reading of each observation and variable straight across, right? John Smith, treatment A, result X. Jane Doe, treatment A, result Y. Mary Johnson, treatment A, blah, blah, blah. The idea here is that even though John Smith, Jane Doe, and Mary Johnson are represented 3 times here, each instance of this is its own data. So if we think back even to the project I mentioned a moment ago, the repeated names are important. So the fact that John Smith got treatment A with this result is different than John Smith having treatment B and getting this result. Each one of these is important. If we look back at the last one, while we can glean that information here, this is not as graphable, right? Or it changes the nature of what it is that we're graphing. And again, that's the output measure that we're really looking for. We want to understand in this example, what are the 3 different things that we want to connect at once? We want to connect the person with the treatment with the results, right? These are the variables and dependencies, each one mattering for this graph. This allows me to select my anchor point for my output. So when I'm in R or I'm using visualization software or what have you, I can choose, is my anchor point John Smith? Is my anchor point treatment A, B, or C? Is my result the anchor point? And then I can build my visualization from there. In this example, I'm not able to do that. The anchor points become quite a bit different in these examples, and I'm no longer able to use each instance as data itself. Okay, so to reiterate, each row then becomes readable data. This is the most important aspect of this. Each row is the readable node on a graph. This is thinking about the output of the data from the start, right? This is the clean and usable data that we want to be able to put into our programs. Now, when I plot this data on my graph, each node will represent the methods of analysis that I'm looking for directly, and it's customizable. So that's the important thing there too. It doesn't lock me into a system of analysis. Now I can change my nodes as I go. Again, each row makes this data usable in a tidy data example. Now, even though this seems like a simple reorientation for data, it really does take some thinking and some time to organize this properly, either at the beginning of your project or in the data collection stage, or in the cleaning and refining stage. Going back even to our examples of the sort of graphical representation of the data, sort of picture and the flow chart of how the data will come together. This is, again, in that thinking that process part out. What is it that we want as our output, and why will it matter in how we're organizing the data from the start? Well, by and large, there are two important components to data management. Sorry, skipped ahead on a slide there. Okay, so those are the major components of tidy data, right? We just outlined those. Now we're going to move into data management, the actual housing of the data. There are two important components to data management: accountability and security. Data management plans, which is one of the things we're going to go over, these account for your project at multiple stages and ensure the control, stability, and security of the data under the researcher's control. So data management plans are required by most accrediting, funding, and supervisory boards, such as large granting institutions and organizational or institutional review boards, depending on your type of institution. A project's life cycle must, in other words, account for the data collection, data storage, data maintenance, and methods and schedule for data destruction. Each step in its life cycle has dependencies and rules for progress, but there are a couple of generalizable notions to note today. One, consistency. It's important to remain consistent with your data. As we discussed above with the notions of tidy data, keeping consistent records both within and about your data will help ensure compliance with data management principles. Data dictionaries and codebooks ensure accuracy for those reading, using, and analyzing your data. Additionally, it allows the ease of access and understanding of what the data represents. Files should be named using a stated convention, for example, and done so simply and consistently. Number two, version control. To ensure researchers are using the same data across the board, a strict adherence to version control should be in place. A good tool for something like this is GitLab, which is available through Turpware. And I'll go into this more in just a minute here. We're nearing the end, I do promise. Okay, so here's some other ideas about consistency, for example. You know, what this really highlights is in your data collection, making sure that from the beginning, you're planning and you've decided your terminology that you're going to be using. So if we're using something like a determining factor for sex and we say female, we want to make sure we use the same version of this. None of these will be read the same way, in other words, by a machine. Each one, even if we're connecting our nodes across, each time it says female, like in this one of these different ways, the machine is going to give us a different output for these each time, thereby cluttering up our data, dramatically. And machines are very literal, by the way. So it's important to understand that, a space before an F or an uppercase F versus a lowercase f, all of these are different examples, right? One little space before makes it a different answer. One little space after makes it a different example, so on and so forth. So setting up your data dictionary to say, when I say male, I mean, the project definition for the term, but it looks like this, and so on and so forth down the line, right? So setting up from the very beginning what it is that your data dictionary will look like and how it will affect your research. This is another sort of component of that planning step that we went through at the very beginning. And you can see an example, again, from some of my data before it was cleaned up totally, what this can be, right? In these examples, these all are different versions of the same thing. So when I'm given this, this example is sine nomine, which is without a name in Latin, that each one of these becomes something different in my total data. So I have to go and create a data dictionary version of this that says, I'm going to use SN, and that's going to equal sine nomine. And that's the way I'm going to represent my data so that it's consistent throughout. Okay. Now, those were 1 and 2, right? We had 1 was the consistency of the data. 2 was the version control, making sure that everybody's working from the same version of the data if it's a larger project. And 3, we're going to look at stability. Okay, stability is to make sure that there is consistent and stable access to the data. And the best way to ensure this is something like the 3-2-1 method for backups. What that enables and ensures is that your data is sort of never lost because of one accident. It would have to be a whole confluence of events that would equal this. So you need to make sure that there are at least 3 copies of the data that exist, that these 3 copies exist in at least 2 different formats, and that one of these copies is offsite and somewhere that you don't have immediate access to it. Now, that is a little bit of a difficulty for there's some difficulty in all of this, and there's, best practices versus reality in some of this. So we'll kind of come back to this here. I do just want to note too, the different formats is a little bit of a trick question as well. A common method is to back up data sort of locally, which means on your computer, and then to use something like a cloud storage, Dropbox or something like this to do the additional storage. That is effectively the same method. Cloud storage is essentially just storing your information on somebody else's computer or a different server. And so it kind of counts as the same thing as local storage in a lot of ways. So the real difference would be something like between the 2 different formats would be storing it locally on your computer and then storing it on an external hard drive, something like that doesn't have immediate write access to it. Okay, but we'll kind of skip past that here. So we had consistency, version control, stability, and security. And this is the important one that's especially important for granting projects or grant-funded projects, or to be in compliance with most IRBs. And this is to ensure that there are safeguards restricting access to the data. And this can mean many things, from de-identifying the data to avoid the possibility of identifying research subjects, to password protecting the data. And also restricting the right access to specific people who are in the research team. So these are the important components there. So we're going to take a quick look here, kind of looking at how different tools do that and help you think about the sort of project management plan in that larger context. So this is an example of a chart indicating the data one lifecycle model. And it's important, I think, even just as a basic principle, to think of data within this larger life cycle. So we talked very early about the sort of planning for collection of data, and then the use of the data, the management and storage of the data using tidy data principles, and then the sort of basic methods of storage and management, and at least some things to think about. But thinking about data as a full life cycle is one of the important sort of shifts in how to work with data. So this is again an example, and no one plan will fit your exact needs. So it's worth discussing with colleagues, professors, and data librarians, and I'll give you a resource for that here, about which plan is going to be best for you, like what will kind of fit the model that you're really looking for. As we can see with this plan, most of the DMP basics, the data management plan basics, are covered, but I would add that there isn't a plan for destruction here. And that's something that I would want in my data, especially if I'm using health data, student data, personal data that may be identifiable at some point down the line. Any number of things that can kind of create a particular problem with security. I would want to have a destruction plan in place, even from the very beginning. That sounds dramatic and overstated, but really all this means is that the data isn't going to languish somewhere on a server or something like this. So to have a plan for getting rid of the data when it's no longer needed. And I know that probably actually sounds a little bit scary because you think, well, what if I need that data set again? And if that's true, if you feel like you'll be kind of returning to the research, then you essentially write that into your plan, that it's an ongoing project. But you'd have to write it into your plan. Most grant agencies, for example, will require that if that is your plan, to have a justification and a schedule for sort of ensuring the data is still secure. And so usually it's every year. Okay. So again, I think this slide is actually out of place, but this just kind of speaks to the sort of notions of data dictionaries and the idea of consistent data and things like this. So these are out of place. So now to kind of transition a bit into some of the resources that we have, and some questions and things if you have those as well. So I want to highlight a good place to start if you're just getting going with a lot of this, and I've just spouted absolute nonsense at you, which is not only possible but likely and also the truth. A good place to start with data planning is our data research services page through the UMD libraries. You can find this at lib.umd.edu/data, and you can contact librarians using this email address. I don't know why I couldn't think of that word right here, and that's lib-research-data@umd.edu. On this page, you'll find things like data management plans, right? So you can look specifically at plans and get an idea of what are available, and you can get some help kind of parsing through those. There are resources for data archiving. We have a link to one of our data sets here through ICPSR. It's not the only one, it's just one of our biggest ones, and it's one that we house in the libraries, so that's an important one for us. And also there's resources looking at data citation and things like this. This is a place that I would bookmark if you're interested in working with data and you have a lot of questions around it. There are also further resources looking at people and data preservation, more about data management services, so on and so forth, and events like ours today. Additionally, we have pages looking at specific areas of data usage. So for example, we have our GIS lab, which you can find at lib.umd.edu/GIS. And this, my colleague Milan, who runs the GIS lab, he offers statistical consulting with GIS data, how to use important GIS tools like ArcGIS and things like this, and can help you work with the data that you have into a kind of manageable function. It can be often very difficult if you use something like ICPSR or some of the other data sources, census.gov, even data.gov, some of the spreadsheets that you can find through there, the data sets that you can find from there. They're a little difficult to work with because they were compiled for a different purpose. But our data experts can help you kind of work with that data in a more manageable form. And I also would like to give a plug for the Research Commons again. Not only in here do we have the workshops and things like you obviously are familiar with, but we also have data consultancy services through the Research Commons, as well as other data tools and workshops and things through that. So I do highly recommend checking this out. Again, that's lib.umd.edu/RC. Now to some tools and things that we have access to for using data, for actually managing and working with data. Turpware, which is, what is their website? It's just turpware.umd.edu, has a number of different good analysis tools, very powerful tools for using all of this. Including SPSS, NVivo, which is a qualitative analysis tool, MATLAB. It's all these different analysis tools are very useful. One that's not listed here that you can find on the web is R, but you need a specific instance and a use in order to use it. We can talk about that more if you need. Most of these are statistical analysis tools, but have different purposes depending on what you're going to be working with. Something like Tableau is a very simple tool, and it allows very quick visualizations of data, provided that you've given it, good data to work with. It creates those simple types of analysis models. There's also Gelfi, which is it's a free tool that's available by the GELPHI I believe is the spelling. And that's a good one to, well, Gephi, I think it is, GEP, it doesn't matter. That's a good one for use as well. When I created my big maps that I showed you earlier, using network analysis, I was using those tools, Tableau and Gephi. You can also use OpenRefine, which is the tool that I mentioned a little while ago. This is the way that you actually can go through and create sort of find and replace methods of removing elements from within your spreadsheet. And it's a very powerful tool, which means you can really screw up your data very quickly. But it's also a very sort of intuitive, rather, tool for pulling pieces and nodes out and putting things in and moving them around and so forth. And it's much easier than doing copy and paste or something like this. And it ensures ways to, if you think back to that example I gave of like the sine nomine, it allows you to kind of say, to create universal rules after you've gone through and identified all of the many versions. You can plug them all in and say, now convert them all to this, for example. So you can create universals as you go. It makes things go a lot faster. I would also recommend using some of the online data management trainings that are available out there, and there are a lot. Even through UMD, we have the LinkedIn Learning available to us. I would check that out to see if there's anything that's available through for data management. A lot of times it falls into, in that context, within like sort of IT type operations and things, but it is worth taking a look. Or like database management in terms of like inventories and things. So just keep that stuff in mind. But I do recommend all of that. Now, I haven't been able to monitor the chat or anything, so I don't know if anything's been coming in. But as I say that, and maybe Gabby, if you could check, see if there are any questions or anything. Wanted to also just throw sort of brief little bibliography up here for you all. And I believe the slides will be available for all of this in the workshop materials library as well. So you can go back and find some of these things. But again, I do highly recommend the Briney Data Management for Researchers and the Tidy Data article. Here we go, the Wickham Tidy Data article. Okay, so I'm going to stop blabbering on there.
All righty. Well,
thank you for coming.
Yeah, thank you guys so much for joining us. And thank you for coming to last Research Commons Common Quandaries workshop for the month of November. And thank you, Jordan, for presenting.
You're very welcome. Take care.